2, test 1, 2. Yes. Hello and welcome. Thanks for joining me in this talk, which, is based, and I can be here because software quality is the story of my professional career. And given this is the 10th edition of NewCrafts, I thought it would be time to remind you why we do what we do as crafters. And my story goes back till 2012 when I became a crafter, but now I have colleagues who could be my kids if I had them. Like they are in their early 20s and they study or they become juniors and they are the next generation of software engineers. And we as crafters need to kind of think again, like, why are we doing this? And we need to explain this. And this is what I would like to share with you. This is a talk that it's very personal, so not everything that is in there might apply to you, so keep that in mind. But I hope you can take away a few things in there. So a little bit about me. I'm an R&D, research and design engineer from Nordic. I work on cloud stuff at a semiconductor company. So my company makes money selling chips that connect your smartphone to your headphones, the pencil on this fruity tablet that you have, or tracks the medical, the pharmaceutical products that you need, and allow that to happen. I work in Norway. I'm not the only one from Norway this year. I hear we have 2 more speakers from Norway, so I'm pretty proud of that. And you can find all my links on codeabycard.com/socials. The slides, I've shared them on my Mastodon profile in case you want to follow the links or whatever, but you can reach me there. So first, let's recap a bit. What is push to deploy? Push to deploy means when I do a change on the thing that I'm working on, and I commit it to my versioning system, probably Git in most of the cases, and then I push it, meaning I push it to the server, make it available to everybody in the team. So I push it from my local computer to the source code repository that we use as a company. But then from there, it should trigger the chain, your pipeline, your flow, that puts it in front of the real customer. And it's not the test system or it's not your colleagues, it's actually whatever makes you money. So it can be, if you're software as a service, it could be your website that it shows up there, or well, if you're shipping software to other of your collaborators, your customers, then it arrives there and they can use it. So this is really the important fact that we need to, we want to optimize for this. And this is when I talk about push to deploy, this is what I mean. Deploy is not just, is it running somewhere, but is it used by the end user? There's a fantastic book. I hope all of you have read it. If not, this is a reminder to read Accelerate, because the first half of this book it explains why push to deploy is so amazing. And then the second part is it actually shows the proof, how they figured it out, the scientific background, the methodology they used is explained. So A, if you want to convince somebody, you can prove that the numbers in there are correct, and B, you can apply this methodology in your company as well to test and figure out and learn more on how to get code faster into production. And so push to deploy is kind of a mantra for me. There are so many principles out there that we learn as crafters. We get some of the very outdated ones, solid. We get maybe, I don't know, TDD is kind of a principle that we learn, or inside out testing, outside in testing, domain-driven design. All of these are many concepts that are very good, But for me, I feel that over my experience over the last years, it's really that focusing on this thing, getting the code out there as fast as possible, applies in any domain that I've worked on. I now work in IoT, but I've worked in fintech, I've worked in the gaming industry, I've worked in advertising, in marketing. So kind of everywhere, this would and will still apply. So it's a universal thing, principle, and it's really easy to remember what to do. How to get there is the hard part, however. So, and why do I want it? So what does it give me? And it's, it's not because I get surprises from it, it's to deal with surprises. And I think like we understand now since like maybe the last 5 years, this is more or less common, is that we live in a volatile world. Everybody went through the pandemic. That was probably the call for the globe that nothing can be predicted anymore. Until before that, we had some financial crises. We had 9/11. We had some of these black swan events that nobody could predict. And even if you can predict them, then you don't know what effect they will have. And that makes them really dangerous, but the overall learning is that it's completely futile to do any planning. Any long-term planning that goes beyond maybe this week. We don't know what's going to happen next week. So, and you have surprises everywhere. Like, you get surprises if you build a product from your customer. Your customer last week said, I want this button on the left side. And then they get a new chief marketing officer and they say, no, I want it on the right side. Here's money, make it happen. I don't care. So, and you can tell, but last week you told us left side and now you're telling right side. And yes, fine, I'm the customer, I'm paying. Surprise change. And you can, and we heard here, sometimes you need to push back and say, no, that's not right. But sometimes it's just like that. They want it, it makes sense, they change their business, so we need to follow their decisions or they will pick another vendor. Surprise success is great to have, but can come at a surprise. You build something, which is kind of, it's going to be a cool prototype. Let's see how that works. And then, like 2 weeks later, you learn, oh, this is the main showcase at the trade show that is happening in Barcelona. That happened to me more than once, where nobody tells you, oh, your stuff is going to be used in that way, but it's just this because it works. We all got that, surprise delays, and I can go endless on. So, and what I want to, I can't avoid surprises, but I need my team and my solutions that I work on be ready to deal with these surprises. And that's how we're pushed to deploy, and it's like having this in mind, I want to be there, really enables me to do this. Because anytime I have this cycle, I make a change, I put it in front of the customer, I put it in front of my team, I put it in front of my stakeholders, and by the way, over the lifetime of your product, your customer will change. Like if you start a new project, like in the first day, you are your customer because you want to see that it runs in the cloud and that kind of the bootstrapping works and that you have all the pipelines in place. Then you are the customer. Then next week, you're showing the product to your product manager and to your team. Then they are your customers. And then like this changes over time, but the idea is the same. The people that give you money, that give you power, that you need to agree on what you're doing, that basically grant you the freedom to keep working on this project, these are your customers, and every time you put it in front of them, you get feedback. I list some features that I get from these fast feedback cycles. Really, if you if you've been following Thierry a bit, he's here on this conference as well. He has a really, really elaborate and very good rant about why feature branches are evil. And if we do push to deploy, meaning we all commit to production code, and there is at any given moment in time we can release our software to the wild, there are no feature branches. That also means there are no long-standing conflicts where you have a long living branch, and then you kind of don't put it in production, but you put it off, and then you come back, and then you need to merge everything together to get it to work. Don't do this. It will save you a lot of work, and it will also not block others if they depend on your work. Just finish your work, just, in very evil word, just finish your work, get it in production, then everybody else can depend on what you've done. Of course, that just finish your work means we need to kind of slice our work in smaller iterations. So we can basically, this one, drop whatever you're working on. When I work not on any project, basically on any project, if somebody comes to me and says, Markus, I need this, I am prepared for this. Because, I can predict, if they say, is this important? Of course, let's assume just they have a good point why they want me to do this. Then I'm able to drop what I'm working on maybe within 1-2 hours. I don't need it immediate, but I can finish what I'm working on, write my test, put it in, push it, release it, maybe put it behind a feature flag, but it's out there, I can drop it, I can get my mind off it. I don't need to remind my colleagues, hey, I'm still working on this, please wait, or please rebase your branch against it, whatever. I push it out, it's done, I can shift my focus. And with a lot of surprises, shifting focus happens constantly. There's unfortunately a big learning in my career is you cannot avoid these surprises. I tried it many years ago. It didn't work out. So, and reiterating it a bit, unfortunately, the surprises also come from many things that you don't like. There are positive surprises, but very often there are unfortunate surprises. So we want to be, and we need to be in this constant loop where shit's fucked, meaning like you have technical debt that you need to change in order to get this new feature, or there's a new feature that you don't want to do, but you have to do it. And then, yes, we need to change it, and sometimes this means we need to completely change our architecture. Alberto did this so good in this previous talk. If you haven't been here, please watch it. Like, we can only make decisions based on the knowledge we have now, but we cannot limit the future capabilities of our systems based on the past knowledge. We learn new stuff, we learn that there is new value to be created, and we need to go where we can create this value, and that sometimes, unfortunately, means we need to change everything. So we need to fuck shit up, so we can find it out. Yeah, so we can find shit out. So this loop, and the faster this loop is, the more we learn, the less painful it becomes. The pain will never go away. It will always be painful. There will always be this phase, oh my God, not again. It's fucked again. But we can get out of it, so we get this good endorphins of, okay, customer is happy, we changed something, my colleague is happy, it is on a trade show, oh, there's good PR about it, my marketing colleagues are happy, That gives me then the motivation the next time when somebody comes to me with, hey Markus, can we change this? I'm like, I hate you for it, but yes, of course we can. So, what we need in order to be able to push to play, however, that is where the craft comes in. Because the plain process of I push code and it goes online, well, that is no magic. Like you pack whatever your artifact is of your source code and put it on a server, and then user does a request, and hopefully it works. And of course, we want to eliminate this hopefully. We want to be certain that it works. And the only way to get to this point is to write tests. There is no way to do this manually. You cannot do manual testing if you have a high velocity. If you change your production multiple times a day, there is no chance in the world that you get good manual tests. You can pay for it, but it doesn't make sense. It economically doesn't make sense. So you need automated tests. And this is, of course, this will give you the certainty that, okay, the change that I'm now making, that's usually where you have a high confidence, because this is the small part in your code where you just work on, you have all the things in mind, okay, it's touching this database, here, this is working, where you probably can get away with little tests to make sure it works, because you also just tested it. The problem is all the other stuff out there in your system that you're completely oblivious to, that it even exists. Yeah, maybe it's not like you've never touched it, you've never seen it. If there are no tests there, but you kind of change something here, then this will break the system. So we need good tests over the entire system to make sure that even small changes, we don't accidentally break something. We also write, of course, tests for ourselves. So I can, even if I have to drop something, I will very often then, if I'm not finished with the feature I'm working on, write a failing test or a skipped test that says, okay, I want like this thing to work like this, put it in a test, commit it, it will be there, it will be marked as skipped, but the next time I pick it up, I can go back to this test, because this test, and I design outside in, and this test will tell me, hey, this is kind of the thing that the user wants to do. And then, okay, all right, I remember. Okay, now I know what to kind of implement under the hood to get it to work. And of course, like this is the fight we constantly have as crafters who believe in testing, is the people who are not there yet, who kind of know it's good, but it's too much effort. This is our job, to make it easy for them to follow us. We can just say, oh, let's go there. This mountain is not so high as it looks like. It's fine. You will be fine. No. We have to go ahead. We need to lead with good example. We sometimes even need to make the path there, because getting started is really, really hard. The thing at the side here, yes, of course, don't have too many tests. Especially when we start with TDD, we start building a lot of tests, and then at some point, we have many tests that cover the same feature or are no longer really useful. Remember to delete your tests, because this will remove cognitive load from everybody who's coming in later and trying to understand what is essentially happening here. Oh, I have like a giant file that tests all the variants here. Yeah, maybe it's not super useful for them to understand it. And this is kind of where we come to the vacation part, or where like I'm now not working on code. I'm here on stage and on this conference. I can, if I have well-tested code, I can even be productive while I'm doing nothing. So and here's an example from my inbox, and this is one day. This is like Thursday, Friday, Saturday, Sunday. So while I'm not working, I'm still producing value. Respectively, not I, but the code base that I created is covered in a lot of tests that I can deal with the messy state that the JavaScript ecosystem is in, where we get dependency updates every hour. And if you want your code base to not be outdated, you basically need to deal with this in an automated way. And having a well-tested code base means if a new dependency changes, a test will be run, it will be checked that it works, and if it works, we bump the dependency and release a new version to production. We get automated security updates. We get not new features because we don't use the new features, but maybe we get performance improvements. And the best thing is if I get back from vacation, I did 3 weeks vacation now, I come back to a code base with basically no new PRs. Like nobody needs to take care of maybe stuff that piles up while I'm away on some of my projects where not more people are working on it. So again, this mindset, push to deploy, means a bot, AI, hello, a bot can create a commit, it gets automatically verified, is it good? And if yes, then fine. So I talked about this, this principle where I can save the work that I'm working on, and I save kind of the intended user feature. That was a hint on what I think is, for me, really the best way to approach this push to deploy, and the fast feedback cycle is using outside-in TDD. Very, very simply explained, if we talk about writing tests, and we have a, let's say we have a calculator and we have a function that adds 2 numbers, or we have a calculator as the product. I want a calculator. So I can implement my calculator and a test for it by really starting to implement all the features. Like I have an add function and I write a test for it. I have a subtract function. I have a root function. And then so I build all these small things that a calculator should be doing. Oh, let's pull in modulo. What else do I have? I need to deal with rendering, maybe exponential numbers, how to display floats, whatever. Like I can spend a lot of time on testing all the components. And then I pull these together into like bigger components. But since everything is covered under here, this goes very fast then. But I can spend a lot of time in the depth of some obscure feature that I might be needing to test it, where outside-in TDD is really taking from the beginning the perspective of the user. It's not deconstructing the calculator into its small components, but it's saying, hey, as a user, I want to add 2 numbers. Okay, then you have your calculator and say, given 2 numbers, I expect a sum. You have a user story already, and you get clarity from your stakeholders. Okay, this is what we want. None of your stakeholders said they want to do modulo. Nobody says they want fractions. Maybe you will never need it. So when you use outside-in TDD, you really focus on the features and you only do that. And this is really, really helpful to make sure that you only implement the necessary stuff. However, that means there will be some maybe shortcuts or not like super optimizations for any kind of use case that will lead you later to do more refactoring. But then at least we know that the refactoring is needed. Like in the beginning, I have a calculator which has the add implemented just in the main function. And if I would have like 20 different operations that I probably want to refactor this in multiple smaller modules so it's easier to compose. But maybe I never need this. So the ultimate hint for you and what to really look into, I think, is behavioral-driven design, which really takes this to an extreme that it decouples the testing, the language the tests are written in from the actual implementation. And BDD takes a step that it moves your basically description of what the thing does. There's a user who has a calculator, and then they input 2 numbers, and they get a sum out of it. They put this in like written plain English text. And now when you have a plain English text, you need something that runs this against your system. But the cool part is that regardless of what you do here, you can change everything in your implementation. You can change the language. You can change from Python to JavaScript. You can change from Java to whatever. This file here with your test, that will not change. And there's a really beauty in it that it preserves your intended behavior of your system in a state that is not like affected by any refactoring. And I've seen this so often that when you start refactoring and removing stuff, you start out uncommenting tests and maybe delete them, maybe move them around. You forget to turn them on or add them back. That can happen, where if you have a BDD feature, it will not. So that is really like an important way to capture the behavior of a system in a way that's also understood by all stakeholders. I know that's a myth that with BDD I can go to my product manager and say, hey, let's write a BDD scenario together. That's not true. Like I don't think many people have managed this, but at least like they can, if I give it to them and say, hey, this is what my system does, it takes two numbers and gives out a sum, they can understand it. They don't get scared by some syntax, by curly braces, and they are willing to read this. And also new people who come in a team, they can start browsing through that without needing to dig through your source code system to figure out what's actually happening and which unit test is relevant. I can talk forever about BDD. It's also amazing because it groups together features or implementation into like things that a user would do. A good example is that you very often see, like you have a storage class, a repository implementation that can store stuff. And often it's really stuff because it's generic. It's not a book storage, or it's not because you don't need that technically. A database can store anything, so your database repository adapter will also store anything. And that's not helpful. Like the user is not using a repository. The user is using your website, yeah? And then they have a list where they can add features. And if you have a feature that connects this part of your source code to this feature, you know exactly when and where it's used. So that was just a bit like glimpse of where like this explodes in complexity of how to test, why to test, what to use, what technology to use, which approaches to use. And the unfortunate truth is that it is extremely hard to get started. The effort it takes, like when there are no examples in your source code base, is insane. And it's super frustrating. And then over time, the more examples you have, it gets easier. I'd say that at some point, like if you have too many examples, it might even go up because then your test suite gets too long, the runtime gets too long, whatever. But that's unfortunately the truth. And that's what I said before. Like we need to be good at giving examples and be a good example. So how do we get there? How do we become good? How can I know I want to test, and like I was in many times in a situation where I came back from a conference, heard about this testing is cool, and then at work nobody writes tests. Yeah? And this is that has worked for me in my career very well. The 20% rule, which basically means like if I have a new project or I have an existing project, but I want to learn something new where this could work. So, for instance, I want to try out event sourcing. I know we have never done this before to make events the like main source of truth for our system. We just use MySQL and do updates, that's fine. But I really want to try it. So I would then risk it. That's the truth. Like 20% means of the deliverable, like using event sourcing is maybe 20% of the features. And if I figure out at some point, okay, it won't work, it is the wrong decision, I still can go back and rip it out and use the old approach. And you can do this for everything. You have 20% of your time. Like you can always carve it out because you have, after some point of time, you have enough knowledge on how to build a system, and very often you repeat stuff. So try to introduce some experiment. Even in your own code, you might learn with it, and if it fails, well, you take a weekend and implement it the old way, and this can even work as a team. You need a commitment to that, but there is room for it. Huh? The next thing is like, and this is thing that worked well for me, but the gist in here is that we become good by learning not everything. We need to find the things that work for you, and that's okay. You can't know anything, it's just too much. But learn some of the techniques that serve you well, and like go deep on them. Because the truth is, there is no one thing how to implement anything. There's always another way to do it. And so the same with testing. I said, outside in is great. There are enough people and examples that say, no, inside out is the only way to go. And we both are right. We get good systems. It's just, for some of you, the one way works, the other way maybe doesn't. I talked about end-to-end testing. Push to deploy also is really depends on one of these ideas here, reproducible builds. You need to learn how to package software in a way that you can kind of repetitively deploy it. If you learn this, by the way, you go into scalability. So I put regex on here because for me, regex allows easy refactoring. I can, using regex, do a lot of refactoring. I personally don't use refactoring tools in IDEs. I too often change IDEs. I was forced to use Vim when I was in my early companies. So I came from a path where I didn't have IDEs in the beginning. So I know how to like clone hundreds of repositories and do changes across many repositories at the same time using regex, because I also am not afraid of code duplication. Another thing here, code duplication is not a bad thing. Because it allows you to quickly iterate. I don't need to make code reusable so I can apply it with all the like perfectly designed APIs in multiple projects. Like, there's no value in it. It only becomes a problem if you have bigger code bases that reuse the same piece of code that has the same bugs. But then, well, you still can use regex to find it and fix it. So that is where Craft really comes in. Craft, one of the ideas is that we try to understand the tools that exist, keep an open mind, that's really important, what is out there, have a look at it, do these experiments, but really find the tools that work well for you. Because only then also can you explain it to your team. Why are you doing this? Why are we doing code duplication here and why not here? How can I deal with tests when I can't run the system on my computer? End-to-end testing, awesome. So this is, we need to have a discussion with our younger colleagues on really, not on a level as this is how I do it, so you have to do it, but I need to enable them to understand why we're doing this, also because they might find a better way, and then can tell me, hey, there's a new way to do it. One thing I would really like to reinforce is that testing, as in test-driven development, is a universal skill. Meaning, if you invest in this will be useful for your entire career. Like, it works in all languages, it works in embedded, it works in high-level languages. There's no programming language that can work without tests. So all of them can work without tests, but there is no language that is perfect, because tests are not for the language, tests are for your assumption. Tests encode your business knowledge and the requirements that you have. Yes, you might write some tests that your data is stored correctly in a database or the integration against an API works, but mainly tests serve as a documentation. That's why I put this blue reminder here. Don't test your language features. If you have a feature that call some functions and you have, for example, TypeScript. Like I see this very often in Lambda functions. Like a Lambda function pulls in some collaborators and then passes in an event to another collaborator. I don't write tests for Lambda functions, which they are very kind of the C and MVC and model view controller. I don't write tests for the controller. If I have TypeScript, which then ensures that I can call my collaborators with the right parameters and everything is like typed. The input is validated, so there's no point in like doing language tests. So we can also only do this, really this fast iteration, if we start owning our own infrastructure. I've never seen it work well with a DevOps or an ops team, which you hand over stuff over the big wall and say, hey, please run this for me. And then you just ship them new features and they are responsible for running it. They're responsible for performance, for migration, for whatever. You need, unfortunately, I think that's the truth, you need to learn more about how to run the things that you're building. And the way to do it is of course, going in the cloud, going serverless, or learning about deploying infrastructure using Kubernetes or whatever works for you. For me, serverless worked very well. But one of the big, important, decisive, I think, books for me to learn and start learning more about it was Rest in Practice. That's the top one. It is really a fantastic book about the main idea is like, how can we build systems that work when everybody failed to build these systems? The only system we know that really works well for billions of people for the last 35 years is the internet. And the internet is built on very simple principles. HTTP requests, status codes, and systems are broken all of the time. So if you keep that in mind, if that's your mode of how you design your system, everything fails all the time, how to deal with that. This book tells you how to use that as a way to design your architecture, and it leads you natively towards a microservice architecture. And you can use this and apply this in many different contexts. And if you then go a bit more into the serverless route, then definitely start reading the new book that just came out a few months ago, Serverless Development in AWS. Fantastic introduction. I'm such a big fan of serverless also because I work a lot in IoT. In IoT, we have a problem that is made for serverless where we have millions of devices which connect to your service. You can't predict it. And it also it needs to scale. Like you can't have one machine that deals with these requests. There's a long talk by me about why this is such a great match. So it's just if many systems have properties where serverless is really a good application. So I think that's you should invest a bit of time into it. Now we are close to the end of my time, so I want to finish with where I said that you need a support system outside of work, because very often you're alone in a company and you're the only one who's pushing this forward. And my journey basically as a crafter was really supported by the outside support I got. Not within my company, but there's a big community out there that can help you. And by the way, there are no certificates. Like software crafter certification is a scam. So you can go to my website and get a certificate. I give them out for free if you want it, but it's a scam. So the solution, of course, is you are already here. So you did the first step. You went to a conference to connect with others, and this is I think the only way that really worked. And if you start digging a bit into the software crafters community, then you will find there's many resources. Yeah, advocate internally. If you're at the point and you need to grow the others, I said that before. You need to be an advocate, a good example, but the inspiration for that, and many have the same problem that you want to push a topic and you don't know how, is to go to external communities. We have a nice website, Software Craft Communities Worldwide, softwarecrafters.org, where we list communities all around the world. NewCrafts is part of this network. There are other conferences, like I really love the Friends of Good Software conference, was former testcraftcamp.nl. Now it's more on software quality, really great communities. Virtual, you can participate here virtually. This is really cool. Organize your own. Yeah, I organize a few conferences. I organize Code Freeze. We're in northern Finland. Come there, 80 people, a lot of snow, aurora, sauna, and maybe a bit software craft talks. One thing that really has helped me, and this no longer exists, but I just put it up here as an example, is I also created my own my own peer groups. I think some people call these mastermind circles, where you just reach out to people from other organizations. And for me, this was a time where I was a CTO in startups in Frankfurt. That's why Tech Leads, Frankfurt Main, that's the region. And I reached out to other CTOs from startups. And we started creating this circle where we was meeting as a group, like 15 people, and then we would have one-on-ones. And everybody was really thankful that this existed. And it takes really little effort. So reaching out to a few people, like finding a co-working space where you can hang out with a few beers and do this once every 2 months. But the important part is that you kind of connect with others and start sharing your things and the problems that you have. Because everybody has these problems. And of course, what I'm doing now is also part of getting better at my craft, because when I stand in front of people, this trains your skill to voice what's important for you. And I really invite all of you. I don't want to be on the stage, see more people like me, white, English-speaking dudes from Norway or from Europe. I want to see more diversity on conferences. And unfortunately, it's a giant problem. So please take the courage and apply. And the first thing you need to do is just write an abstract. You don't need a presentation. You just need 4 sentences and 3 takeaways, and that's it. Submit it to a conference like NewCrafts, and if they take you, then you have to make the presentation. I made a video about this, how simple it is. And if you want to write an abstract, I will help you. We need to get more. I've been doing this too long, so there need to be more people who are doing this not so long as I am. But it's a way, of course. I get to go to the speaker's room. I get to meet amazing other speakers. I can just chat to them and learn about stuff, and get the insight. That will, again, help me improve my skills. It's really invaluable. So I will be closing with what's the point of this? I talked about, okay, push to deploy, we are learning, we need the skill, and I'd like to reiterate, why are we want to be good at what we're doing? And basically, Alberto said it before in the call, we can't just put shit in front of our customers. Everything we do needs to be very good. If it's a good idea, shitty executed. If it's the most amazing screen design, but the response time is 15 seconds before the page loads, nobody's got to see this amazing idea. They will be gone. So let's skip that. The craft itself is not an end to itself. It's really, we support business ideas with our craft, and through us, we are the conduits that take the business idea and I might not agree with all of them, but I don't have the data to say to them, hey, this idea is really shitty. I need to treat any idea that's coming to me fairly, give it my best to put it in front of the user and let the user decide if this idea is shitty. Because they are paying my salary, not I. So that really is why we need to be good at what we're doing. To give any idea that is out there a good chance to survive and maybe to be the surprise success we have been preparing for. Thank you very much.